All right, welcome everyone. Today we're going to be talking about relationships and the Django server. In part one of our lecture, we'll be learning what are relationships in regards to the Django ORM. We're going to be talking about one-to-one relationships, how a serializer works in one-to-one relationships, one-to-many relationships. Again, we'll talk about the serializers then, many-to-many relationships, how the serializer method will work for that, and applying many-to-many relationships to a moves app within our Pokemon application. In part two, we're going to go ahead and dive into what is run server. What does that command actually do within Django? We're going to talk about creating URL patterns. What is the path function and what parameters the path function needs or wants? We'll talk about creating URL views after that. Views, not vice. And then we'll talk about what is a request and how to handle URL parameters like we did with React. All right, perfect. Does anyone have any questions over what we'll be covering today? If no one has any questions, then let's dive in. All right, Django ORM associations. So pretty simple here. We have a one-to-one relationship, right? We have a one person that can only have one passport. Another common example is one person can have only one social security number. And the way we actually write this in code is going to be with models dot one-to-one field. And then notice that in those quotation marks, I have model, right? That is the model that we're trying to reference to. So for example, down at the very bottom, this would be written within the passport code, where the owner of the passport would be a one-to-one field to a traveler. All right, then we have a foreign key relationship. A foreign key relationship is how we handle many to one. Luggage. Much luggage can belong to one person. When you go over to an airport and you're checking in your luggage, they always have you decide, even if there's multiple people holding multiple bags, they always have you decide what luggage belongs to what person. That's a many to one relationship. It's the way the database within the airport would be able to track that, right? An owner, which again would fall within the luggage perspective, has a foreign key relationship to the traveler. Well, now in both of these examples, you may be asking yourself, wait a minute, why is it that the owner falls to that this line of code where we're making the relationship is within the passport, and the line of code that is making the relationship is actually within the luggage? Well, when you're thinking about making these relationships, you got to make them from the child perspective. Just like we learned in SQL, there is a cascading directive whenever something falls from the database. Meaning, if my traveler no longer exists, I should not be withholding any data regarding to any luggage, right? For if my traveler is no longer within my airport, there's no luggage that I need to be able to track for that traveler. And same thing up above. If a traveler dies, there's no longer a passport that belongs to that traveler. So as that traveler disappears, so should the children of said traveler. Now, this applies to both of these. As far as foreign key relationships, which is a many to one, and one-to-one relationships, which is a one-to-one. Where it doesn't apply is many to many. So many to many relationships are going to be tracked through Django in the backend, where I'm going to actually take a look at what kind of relationship management happens within the database. But what we're actually going to see in code will be a series of sets. A set will be generated that will hold a number of IDs belonging to the passengers that could belong to each plane. And under the hood, Django is going to create a connecting table that will be managed strictly through Django. We won't ever actually create a connecting table, although the many-to-many relationship in Django is very powerful. Sometimes you may want to make the design decision of making your own actual connecting table instead of just letting Django try to handle it on its own. But we're going to explore the many-to-many field We know how to build connecting tables already from SQL, and the concept doesn't change as far as building a connecting table between SQL and Django's ORM. All right. Does anyone have any questions? Perfect. So here we have a different types of associations, right? We have a dining set. Now, the dining set is the very first thing being created. We can see that at the very top. Now, the dining set is created because it is the parent of everything else that could be attached to that dining set. So there we can see that it's a 6-piece set. We have a color that has been created for it. There's a stool. Well, that stool, there's only one stool that can belong to this dining set. Well, we can see in line 47 there's a one-to-one relationship to the dining set. And then at the very end of that one-to-one relationship in line 47, you can see there's an on delete models.cascade. That means that if my dining set were to no longer exist, any stool that is related to that dining set would also no longer exist within my database. Now you'll notice there's also a related name field. We're going to cover what that is, but essentially a related name field gives us the ability to access the model of stool from the dining set. It would be as if we wanted to type dining set dot stool. Well, what would be populated would be the one stool that is connected to the dining set. We'll see that in code here shortly. Then we have chairs. There's many chairs that belong to one specific dining set. So there we see that it has a foreign key relationship. Again, it has an onDelete.cascade and a related name. Now notice that the order of that onDelete.cascade was switched. This remained the same. Well, these are assumed values, right? We're passing into an initializer because this is still a class. It's written in OOP. We are still passing an assumed value. But then after that, we're dictating which attribute it is we're trying to access and giving it a value, such as models.cascade, chair, or stool. So the order of related name or anything that we're actually calling with a value is not going to matter. The assumed value should always be the one that comes first, and that's always going to be the model that you're trying to relate to. All right, and then finally we have a kitchen, which many dining sets can belong to many kitchens, right? And we can see that it's being managed here. There's no related name. We could add one if we wanted to, but the onDelete method is actually a lot more complicated to manage when you're working within this within this many to many field. We'll see how that works here shortly. All right. Any questions? Perfect. Doesn't seem like there are any questions, and we're all ready to see some code. So let's dive into it. All right. So for this portion, we're going to take a step back from the Pokedex project. We're going to start working within this associations project. Now, this associations project isn't anything crazy. We can go into settings.py. We come down. We can see we have REST framework that has been installed. That's to give us access to our serializers. Here's our apps that have already been created of one-to-one, one-to-many, and many-to-many. Each one will be holding a dictated example. And then we have our Django associations backend that's attached to PostgreSQL and an associations DB. All right. And we probably won't use TL draw too much today, so I'm actually going to try to widen this up so that there's less noise on the screen. Perfect. Now there's settings.py. Again, nothing that should be brand new to us. Let's go into our one-to-one relationships and start talking about this model. So here we have a social security and a person. We're going to keep these pretty basic. So social security, we're just going to write SSN is equal to models dot, let's call it a char field for now. And let's give it a default of 111, 11, 111. There you go. And now for a person, we'll just go ahead and pass a person in there that has a char field with a default name. And let's do Adam for this one. Now notice the order in which these are created. If a social security were to be deleted, and I make some sort of relationship here between person and social security, well, then I would have to handle what to do to a person if the social security is deleted. That's not necessarily the behavior that I want. Instead, I would want my person to be created and the connection to be happening at the social security level. So now I can say person, say models dot 1 to 1 field, not relationship, pass in the person, say on delete models dot, and there's a couple. We can either do nothing, set null, or cascade. The most commonly used one is cascade. And then we could add a related name. Now this related name could be something like SSN. Now what this related name field does is essentially down below, now I have something called SSN, which is equal to the related social security entry that has a relationship to this person. All right. I guess it might be a good thing to open up a playground as well so that we can see this thing. Right, we can go from 1 to 1 dot models, and I'm just going to import all there. All right. Now let's create a new person. So I'm going to say new person is equal to person. We don't actually need any parameters. And then let's go with new social be equal to social security, where the person will be equal to new person. That's the only parameters that we'll be passing in there. All right. Now we'll go ahead and print new person. And we will print the new social. Let's take a look at this. So there we can see a person object of none is being created. Interesting. And then we have a security object of none. I'm not sure why they're coming back as none just yet. Likely because they're not saved. Let's go ahead and try to access this way. Let's say .name. And let's do .ssn. All right, so there we have Adam, and we have the default value there of SSN. Well, now let's see what happens if I try to access through the Social Security my person's name. Well, I could go new Social Security .person .name. All right, so what's happening there? We go into the Social Security table. We then grab that person attribute, but the person attribute is related to another class. So that brings us to the class of person, and it gives us the name. Nice. All right, well, how do I do this backwards? All right. So currently, I have a new person. How could I access the SSN that's attached to this person?
The related name
Yeah,
that you pass.
perfect. So I could say print new person dot SSN because that's the related name that I passed, which probably isn't a good idea. I should have named it a little bit more. I should have been a little bit more descriptive. And then SSN, which is the attribute that we're utilizing in there. And that's how we get 111, 11, 111. Again, we could change this up a little bit. Maybe we just call this social. That might be a little better. Let's go ahead and exit so that we can update this information. So we have name dot social dot SSN. Now notice it's not able to recognize it inside of code. It's not highlighted as an actual attribute because person doesn't actually have an attribute as far as Python is able to track. What's tracking this related name relationship is Django itself while it's running. So we can go into Python, manage.py, come back into the shell, paste our code, and there you can see we're accessing the social security number there. All right. Well, now how does that work within the serializer method? Well, the serializer is almost the same. I would want to see details, information regarding the parent, or we can have it backwards. It's really more of a design decision on how we want it. Oh, I see a question come up. Go ahead, Andy.
Um, the question was related to last thing you said was if the person doesn't exist, then there isn't a relationship anymore, right? So I was wondering if the person doesn't exist in this case, then the relationship still kind of exists, although it's not being used. So I'm kind of confused on that part.
That's a great question. Let's take it a step further here, actually, before we go into serializers. Let's go into saving this new person. The one does not exist. What is happening here? Let me see here. All right, so currently I don't have anything that's being created, right? So I wouldn't be able to save it. I got to make some migrations. So that's where my issue was coming from. So let's go ahead and do that. Python manage py, make migrations. Da, da, da. Yep. I didn't want to default. All right. I'm just going to go ahead and do this number. All right, all I'm trying to do is I'm trying to troubleshoot a pre-existing migration that already exists. Please do not let this confuse you or try to keep track of what I'm doing because this has nothing to do with our actual relationship here. All right, great. Actually, delete all of these. All right, so there we go. Now we have an ID and a name from a person in the one-to-one relationship.
So you had pre-existing databases from doing this lesson before, and it was causing issues, and so you just dropped them and reset everything.
Yes. And then I
Okay.
also got rid of the migrations folder so that it wouldn't interact and they would recreate a new initial migration. All right. So now let's go through this process, right? We have our new person. We're going to go ahead and save them. Then we're going to go ahead and take a look at the database and see what comes back. Once we see what comes back, I'm actually going to delete new person. And we're going to see that social is going to be deleted from the database as well. So let's take it one step at a time here. We'll come back, dive into our shell. And start off by saving our person. Let's see. All right. Now I can go ahead and run my select query because my person has been saved. Let me go ahead and press enter just to make sure that that was executed. And you can see that there's a new person entry. Adam has been created. Well, currently there's no social security related to Adam. Right? I can go to one-to-one social security. And you can see there's nothing related to Adam just yet. Let's go ahead and create it. So there's our social security that has been saved and has our relationship to Adam now. There you go. All right, so now there's an actual relationship between Adam and this social security. Well, now what happens when I do new person dot delete? So I see new person dot delete method, and it tells me, hey, new person has been deleted. And it also lets me know there's a person that has a one-to-one to social security that has also been deleted. Well, let's see this. There's no person anymore in my database, which there was Adam before, but now there's no person because I have just deleted it. And if I go to Social Security, there's no longer a Social Security present because as that person stopped existing within my database, so did the Social Security. Did that address your question, Andy?
Yeah, I did. I think so.
All right, awesome. Go ahead and exit here. So now we got a little bit of a look at what we're trying to do there. Oh, let's see. All right, this works. We'll do it this way for now. And now let's go ahead and take a look at how our serializers are going to work. Now our serializer, this is kind of up to you how you want to manage your serializer, but only one of them will be able to be in detail. And the reason why only one serializer will be able to hold detailed information is because it actually has to call on the serializer prior to. So this is what I mean. We'll go ahead and make our class meta. we know that the model we'll be utilizing here is going to be the person model. And let's quickly just go into fields equals underscore all. This is going to be almost the same exact code down below, with the exception of switching person to Social Security. All right. Well, if I wanted to see a person within my model serializer, I would actually have to bring it down and say, hey, a person, instead of just being serialized as all, I want you to use the person serializer. And serialize this code. And let's see what that looks like in our playground here. We're going to go ahead and save all this information. And then I'm going to utilize my serializer to take a look at my code. So let's say social serial be equal to Social Security serializer and pass in a new social. From there, I'm going to do social serializer dot data. I want to make sure this gets printed onto my terminal. Probably won't need SQL for a while, so I'm going to go ahead and close that down. I'm going to copy all this information and enter my shell one more time. All right, so there you can see the print statement of my serializer and my data. We have the ID of 2. This belongs to the Social Security. And then here we have the entry for that person. All right, that person has a name, Social Security, 111. All right, great. Well, if we take a look at our model, notice that if I try to call the person serializer now, so if I say, hey, I want to see the person serializer, and I want to run this information on this new person that I've created in the past and see their data, well, that just gives me the ID and name, but it isn't going to describe to me the Social Security. Well, you could say, why can't we just add this line like we did before, right? What if I just wanted to do, hey, I want the social attribute, because that's the related name field that we have down below, to be equal to the Social Security serializer. Well, notice it's giving it to me in yellow. Why is that?
The stack that's defined below.
Yeah, exactly. It hasn't been defined yet. It doesn't exist. So I myself have to make the decision on how it is that I want this to be identified. So if I wanted to have that behavior, I would have to switch them this way. So now the Social Security would be established before. Then the person serializer would be created, and I can see the social through the person. Let's go ahead and try to dive into this one more time. Let's go ahead and do person serializer that takes in the new person dot data. And just quickly, I'm going to do new person dot delete to make sure that my database stays empty. All right. So let's run it up to the same exact point as we did before. Well, when we execute this code, we can see the new social is created, everything gets saved. I then do it into the social serializer. Well, now person is just represented by the ID. But now when I run the person serializer and ask for the data, well, here's my ID. Here's the social that I wanted. And then I get the name regarding Adam. So this one's going to be your design-based decision how you want it to be. As far as which one is it that you want to where you want to show the representation. What a lot of people do is what they'll have a regular serializer and then they'll have something called a person detailed serializer. And then the person detailed will include the social security inside of it, right? That way you could have different serializers for different types of responses that you want in your program. All right. Does anyone have any questions over one-to-one relationships and how to manage them within your programs along with serializers? Let's hear it, Carlos.
Is it normal to have maybe just a bunch of different, like you mentioned, like a bunch of different serializers just to give you the information that you want, or to have more of a general serializer where you can just grab the information you need in the front end?
Sorry, could you repeat your question one more time?
So let's say like you said, you have the person serializer and you have the person detail serializer, which gives you two different outputs when you get the data. Now, let's say you want to see, I mean, I guess the person's kind of limited here, but um, does it, do you want to serialize it? It just gives you a bunch of information and then you can just um, on your front end, just like whenever you're handling the information, the data, just filter it down to what you need? Or is it more common to just have a bunch of more targeted serializers to give you specific information, specific fields only? I don't know if I'm explaining this right.
Yes, you are. Thank you. No, I appreciate you rephrasing your question. So, what's going to be more common practice is to have specific serializers for the data that you want. And it kind of depends on the API that you're building. If you're building a general API that's just for people, like open, anybody can use it, and you have pagination built into it, kind of like the Rick and Morty API, right? The Rick and Morty API spits at you just a ridiculous amount of detail. Um, and it's not very targeted. You'll notice that their endpoints, there's not that many endpoints, and the endpoints that do exist are very much here's everything pertaining this one endpoint. Like good luck, you filtered through it. It's up to you. Right. A different perspective would be the Poke API. When we ping the Poke API for 20 Pokemon, there's a serializer that's meant to only return the name and the URL for that one Pokemon. But when you ping a specific Pokemon by ID or name, it doesn't do that, right? It doesn't just give you a name and a URL. It gives you all of the details pertaining that one Pokemon. So that would be an example there. And it also just depends on the way you're building your application. What serializers, or when it comes to deciding um, the specific question that you just asked when it comes to making a decision there is how light do you want your responses to be from your server, or how heavy is it that you want your server logic to be when processing a request? Right. So that just kind of falls more into what would be more efficient for you and the server rather than what's more efficient for the client. Because when it comes for JavaScript, JavaScript could iterate through an object extremely quickly, right? They could figure out how to get to a key value pair. But you yourself have to decide how much of the database do I really want to overload when this request comes through and then send back to the user. Does that answer your question?
It does. Yeah, thank you.
Of course. Andy?
Um, my question maybe relates to Carlos's. I was wondering yesterday you were doing a separate serializer file, and today you're putting it into the models. Could you explain that?
Strictly just to make sure that everything stays in one file. I'm not actually, we would typically actually have a serializer file. I'm just actually doing it all in one so that all of the code belongs in one. This project is just to demonstrate how relationships work and how to handle that information. I wanted to make it simple so that all the information is inside of one file for you guys to look at rather than having to iterate through all these separate files and try to figure out the code that I'm writing. Does that answer your question, Andy? Of
Yes, thank you.
course. Any other questions? Okay, perfect. Well, now that we went in depth in one-to-one relationships, let's go ahead and try to take a look at how to handle a one-to-many relationship. So now a one-to-many relationship, we have customers and orders. Well, we know that the parent would be a customer, which again, nothing too crazy. We'll go ahead and do a char field here, keep it as minimal as possible. Let's do a default there. Do a Avila, and let's do order number. Or actually, let's say order cost, which could be a models.decimal field. Oh man, let's see, which has max digits. Let's do 5. And then decimal places 2. And finally, we can pass in a default of, let's say, 1599. All right. Now, one customer can have many orders. So in this case, what I would say is, hey, the customer making this orders would be as follows. It will be models.foreign key relationship to the customer, where the related name would be orders. And the onDelete method, well, again, I'll say models.cascade. All right. So there I have my information. I know that because I have that related name field, there is now an orders down below that will return a list of objects. Now, why is this one returning a list, whereas my one-to-one relationship was only returning a one direct object? Why is that?
Is it because you're using the foreign key?
Yeah, I'm using a foreign key, meaning many of these orders will fall to the customer. So I need to be able to account for multiple orders. All right. We go into the order serializer. There, I'm just going to do my class meta, where I know that the model that I want to reference will be the orders model. And for fields, again, I'll just have my __ all. All right. For the customer, we'll have something similar. We have the class meta. The model that I want to reference will be my customer model. And the fields that I want to see will be __ all. All right. Well, in the customer serializer, I want to be able to see my orders. So how would I call the order serializer for the customer? And I'll bring up what we have here in our one-to-one to try to give us a hint over what we've done in the past.
It's the same thing, same serializer, just that many equals true.
All right, great. So let's go ahead and apply that. We're going to go ahead and do orders because that's our related name field. We're going to do order serializer. And a very key thing to add there is to make sure that we're adding the many argument to say that it's true. Now, why is this important? Why do you, I think that was Carlos. Carlos, why do you think that we should have a many equals true?
Otherwise it would just, I would assume it would break, but you basically just wanted to iterate through that list of orders that's created for that customer.
Exactly. So yesterday we learned in regards to serializers, if there's going to be many of them, excuse me, we need to have a way to actually implement the many equals true so that it learns that it needs to iterate through that list. Fantastic. All right, go ahead, Michael.
Does many equals true make it so that it has to be many, there has to be multiple, or does it allow it to have a single relationship without that?
If you're passing many equals true, there has to be an iterable list that gets passed into it.
Okay.
All right.
So it could just be a list, but it would just have the one object, or it can be an empty list, right?
It could be an empty list, but if you pass in an empty list, it's just going to return a serializer.none, where it's going to specify the fields that it's going to be working with, but it's going to hold no values to any of them. All right. So now let's go ahead and dive into this customer here. And actually, before I dive into it, I might want to make and migrate. All right. So Python manage py, make migrations here. And this one's going to be our one-to-many application. All right, Python manage py, migrate. Everything's inside of the database now. And now let's actually write some code. Let's say from my one to many application dot models, I want to import all. Now here I'm just going to create a new customer. So new customer be equal to customer. We know there's no values that need to be added in there. And I'm going to create a series of orders. So for IDX in LEN, or excuse me, 5. Hopefully I didn't forget simple Python here. Let's go ahead and do the order be equal to orders where the customer will be equal to my new customer. All right, so there I'm going to create a series of 5 orders, all for this one customer that's been created. Let's actually do new customer.save there. And let's do new order dot save. We're going to run this block of code and see what our PostgreSQL database looks like. From there, what we're going to do is we are going to go ahead and query all of those orders so we can see them. I'm going to say order serializer, where I am going to grab orders.objects.all and pass in many equals true. And then I'm going to grab that customer. So I'm going to say customer, and then you want to see that data. All right. Then I'm going to print that customer serializer, where the data is from the new customer. And I want to watch that data as well. All right, let's dive into it. So we go Python, manage py, shell. And within the shell, we're just going to run this here to grab all of these orders. All right. Again, I'm going to dive into PSQL. And I want to see the customer table first. So there it is. My one customer was created, which is Avila. Now I want to see the orders. So there's my 5 orders that were created. All of them are $15.99, and they're all in relationship to my number 1 customer, which is Avila. All right, perfect. All of the creation of my data was created correctly. We can see there how this is a one-to-many relationship, right? The many portion is that many of these order IDs belong to this one customer ID. All right, great. Well, now let's take a look at the data for all those orders. So all of my orders utilized in a serializer are coming back as such. Right? That should be familiar to what we saw yesterday. But now if we want to take a look at the new customer and their data, well, you'll see my customer ID is of 1. The orders that belong to that customer is a list of objects, all being represented for that one customer. And then I have my customer name, which is Avila. All right, and just like before, everything is on models.cascade. So if I want to remove everything from my database, including the customer and all of their orders, all I need to do is say new customer dot delete. And upon doing so, it's also telling me there is a one-to-many relationship of orders. There was 5 of them, that all of them have been deleted. So now if I go to pSQL and I take a look at orders, there is none. And if I take a look at customers, there is none. All right. Any questions regarding one-to-many relationships? Perfect. It doesn't seem like there are any questions with between one-to-one and one-to-many. With just these two factors, we should be able to create a connecting table moving forward in the case that we're not big fans of the many-to-many field. But let's go take a look at the many-to-many relationships now. Close that up. All right, many-to-many relationships. We have books and we have authors. Great. So now for a book, we're just going to go ahead and name it, give it a title, where the title is models.charfield. And let's give it a default of this is a book. All right. And then we have authors, where authors, they have a name, excuse me, of models.charfield. We'll go ahead and give it a default of Francisco. All right, and then finally we have a many-to-many relationship because many authors can author many books, and in many books can have many authors. So books will be as follows. Will be models.many-to-many field. And this many-to-many field will be attached to books. There's no on delete portion. However, we could have a related name, or we can say authors. And we know through that related name, there is now an author section, which will return a set of IDs. Let's take a look at what that looks like. I'm going to open up my playground here on the right-hand side. I'm going to say from many to many dot models. I want to import all. I'm going to have a new book being created. This one's going to be of books. Going to create a book 2, which is going to be an instance of books where the title will be equal to, this is an article. Then I'll have an author. So author 1. Now I'll have a secondary author, where the name will be equal to Adam. All right. So now I have 2 books and 2 authors that will be created. I'm going to go ahead and save them both. So new book.save, book2.save, author1.save, and author2.save. The very important thing to bring up here is you cannot make relationships in many-to-many fields unless they have been saved first. And notice that as I'm creating this information, I'm not actually passing which books I'm attached to just yet. Well, let's see. This is different behavior, so let's take it a step at a time. I'm going to go ahead and exit the shell. I'm going to make my migrations. For my many application there. Okay. Python.
You left out. Yep.
All right. And now I can go ahead and create model author serializer. Did I use model? Of course I did. Why wouldn't I? All right, that works. Actually, that doesn't work. There you go. All right. And now we can go ahead and migrate. All right, so just like we mentioned before, brand new behavior. I want to take a look at how this works. So I'm going to run Python manage py shell. And I'm just simply going to run this block of code here. That should create for us those 4 instances. You see there was no error coming up. Even though I didn't make an attachment, it allowed me to create these instances without any sort of problem. And if I go to select all, actually, let's do \d here. Let's go to the bottom. So here we have a many-to-many authors. We have a many-to-many books. We have a many-to-many authors ID sequence, and we have a many-to-many books ID sequence. But there is a new table that I never created. We have this many-to-many authors underscore books. All right, so let's go ahead and take a look at these. So I run select all from many-to-many authors. Okay, so there's my Francisco and Adam, which is what I expected. I run select all from many-to-many books. And there's that this is a book and this is an article. Again, what I expected. Well, now if I run select all from many-to-many authors underscore books, well, that returns a connecting table of a one-to-one ID sequence between author IDs and book IDs. All right, so there's my connecting table. Never that I created myself. You can see in this block of code that I never once asked Django to create another model that would connect my authors and books. Instead, that many-to-many field created that connecting table on its own. Right, well, that's great, but how do I manage this connection? Well, there's 2 ways, right? I can enter from a book and say, hey, there's an authors here. Or actually, let's take a look here and see it. Going to go into authors, or excuse me, what is going on here? Going to go into author 1. And author 1, if I run books, oh, excuse me, it's author 1.books.all. You'll see that I get back a query set. If I go into my book, so if I say new book dot authors dot all, again, I get back a query set. So how do I manage this? I can go into new book dot authors dot add, and I can add an ID that belongs to an author. So in this case, let's go ahead and do author 1 dot ID. Gonna pass this here. All right. Now let's go into new book dot authors dot all. Well, now when I go into new book dot authors dot all, a new ID has been added there, belonging to author 1. If I take a look at this many-to-many table in SQL, we'll see that now there's a relationship. The first entry has been entered, where the very first author has a relationship to that very first book. All right. Well, now I want this book to also have a relationship to the second author. So I'll say author2.id. And again, under the hood, this authors is a set. Now, because it is a set, that's why I'm utilizing the .add method. All right, so now I'll go ahead and run that 2 for ID. And if I take a look at all, well, now I have a connection to both of them, where both authors have authored this book. I'll run that selection again. Okay, so here's my author IDs. There's two separate authors related to one book. All right, well, what if I wanted to do the opposite direction? I want an author to have written the article of book 2. Well, I can say author 1 dot books dot add, where I can call book 2 dot ID. Well, now when I run author 1 dot books dot all, how many elements do we expect to see in that query set? All right, see Marshall putting up 2. Yeah, we expect to see 2 because it has already authored this new book, and now it's also going to author the article. All right, so there we go, where we have books of object 1 and object 2. If I run my query one more time, that's where we'll see our many-to-many relationship. All right, so author 1 also helped with book 1. Author 2 helped with book 1. Author 1 helped with book 2. So there's many books that can be written by many authors. All right, so now we saw the relationships of everything happening in the back end and how everything's being related to inside of my associations table. Well, the behavior in serializers kind of still stays the same as far as in if I want the details to be in the author serializer and the book serializer has to come before and vice versa. So let's say I want it this way. I want to see everything coming down from my serializer. So I want to grab book serializer. I'm going to say class meta. I'm going to go into model equals books. And then I'm going to say fields is equal to underscore underscore all. All right, pretty much the same exact thing down below. Just instead of books, I want my authors. All right, let's apply here. This is all going to be erased as soon as I leave. So instead, I'm going to grab author 1, and I'm going to leave a very clear comment here that's going to say part 2, which is going to be equal to authors.objects.get, where ID is equal to 1. I'm going to grab author 2. Going to grab book 1. All right, and book 2. So there you go. I'm going to grab all 4 of my objects first. And I can go ahead and go into my serializer. For now, I'm going to take a look at my book serializer. Which is going to take book 1. I want to see the data that comes back from it. And then I'm going to take my author serializer, which is going to take, we'll do it right now, author 1. And I want to see the data that comes back there. All right, let's exit, enter the shell one more time. Let me bring back that import statement. And now let's take a look. How about
Francisco,
yes.
line 44. I don't think you have a book 1. I think it needs to be new book.
Book 1.
Oh, no, you're right. You
Okay.
changed it.
All right, awesome. All right, so there's my book 1 serializer. We can see that print statement coming back. where we have the ID of the title. And then we can see Francisco. Well, now Francisco, when we take a look at books, he has the IDs or a list of IDs of 1 and 2. Well, it's a list. So maybe I could just pass in my serializer, right? Maybe I can do something like, hey, books is equal to the book serializer and pass in many equals true. See what this does. I'm going to exit one more time and then type it all back in. Well, now I'm getting an error here.
You didn't do your import.
Oh, that will do it. You know what? Let me go ahead. That's the problem with copying and pasting. Just grab this information, paste it, and run it. Well, now we can see that worked, right? Our book serializer is there. Books is that grabbing that information, still just grabbing that many equals true, and it's able to get the title for each independent book and return it back. And that's how you manage many-to-many relationships. All right. Perfect. So that's going to cover all of our relationships material. Does anyone have any questions regarding many-to-many relationships, one-to-one relationships, or one-to-many relationships? Perfect. If there is nothing, we've been going on for quite a bit, and this should allow us to be able to tackle down our assignment. So let's take the next 57 minutes, and let me pause the recording actually before I keep moving forward. All right, welcome back, everyone. Now that we have learned about relationships, let's dive into actually applying some relationships into our Pokemon application. We're going to create a separate model. Now, typically you want to isolate models to an app. An app belongs to one specific data table because, as we'll see here in the future, functionality is going to increase so much that if you try to put multiple models inside of one application, it's going to really put a lot of code in every single one of your files. So to try to keep things isolated, then we're applying the single responsibility principle. We want to make sure that we create an app for every model. So in this case, we want our Pokemon to have moves. So we're going to go ahead and utilize manage PY to go ahead and create a new application. Now, this application, we're going to name it the Move app. Now, I'm going to go into my Pokedex project, come into my settings. I've now created a new app, so I can name it the Move app. Great. My app is installed. Let's go into moves and actually create a model here. Now, because of time, we're going to go ahead and move through this rather quickly. This is already in our curriculum. I'll go ahead and share the link here with everybody, and then we'll do a quick overview over what we've been creating. I see a hand go up. Go ahead, Justin.
So are you saying one model per app or
Yes, I am saying that if you're
okay.
creating a new model, right, and it's not like a small one, like it's a one that's going to have an entire functionality, all of CRUD applied to it, you want to create an independent app. Now, if it's
Okay.
small and attached, you could probably keep it within the same application.
Okay, so this means that for each one you're gonna have for each I guess app with a large model, you're gonna have okay, never mind, it's making sense. Thank you.
Okay, fantastic. Looks like we have here a validators portion. So let me go ahead and make sure that all of that is being created. Oh. All right, and in validators pre-Y, we want the validate move name. All right. Perfect. So there we can see we have our move. Our move has a meme, some accuracy, some PowerPoints, power, and then a string method that we can utilize to actually see this move. All right, we could actually move on into test cases to make sure that this is working correctly. We've already covered test cases, so we're going to go ahead and skip this portion. All right, and let's go into creating a serializers file as well. Now for my serializers, you see it being created where not all of the fields are being included, but rather just the ID, name, and power and accuracy. Now, if I'm doing it this way, this is probably going to cause an issue for all of my serializer data to be created. So rather than just having the selected fields, I'm going to do all. That way I can actually create new instances utilizing the move serializer as well. All right, so it looks like the only thing that we need to be able to create a move is going to be the data of name. I can come over to the model here. It looks like my name is the only one that doesn't have a default value. Everything else has a default. So I'm just going to go ahead and quickly create a new validator. Let me make sure all of this is commented out. Or let me go ahead and create a new move here. So I'm just going to say from move app dot serializers, I want to import my model, which is going to be psychic, or excuse me, it's going to be a move. And then we want my move serializer. All right. Once I have that, I can go ahead and create my new move, where my new move utilizes the move serializer, and data is equal to name. We follow psychic, which is going to also follow my validation here. It looks like this is allowing for two or one or more words, so that's great. It's allowing for 2 words, I apologize. I'm assuming that that's because if I want to do something like wing attack or something like that, I want to be able to implement it. So in this case, I have the model of psychic. I'm going to say if new move is valid, then I want to new move dot save. And then otherwise, I want to see the errors. All right. Go ahead and apply this. I'm going to do Python, manage PY, make migrations. All right, so there's my create model for move. Python, manage PY, migrate. Now there's an actual instance of a table inside of my database. And now I can enter the playground and actually move around with the serializer. So Python minus py shell. Going to go ahead and copy all of this to the shell. And when it runs through, we can see that a new move has been created for psychic. All right, I can see new move dot data. Oh, that is not a function. There you go, new move dot data. And I can see all the information regarding that new move. All right, as of now, nothing new that we have encountered. We have seen this already a couple of times. But now let's actually apply some sort of relationship, right? We know many Pokemon can have many moves. So we'll go ahead and actually apply a many-to-many relationship to our Pokemon model. So in my Pokemon model, I'm going to go ahead and add a brand new field where I'll go ahead and say moves is equal to models dot many-to-many field that will have a move. And I actually need to import this. So I'll come over to the top and say from move app dot models import move. right. Don't know what that's about. I'm gonna take that off. I don't know if that's useful to anybody. All right. So there's the move. Well, I have the related name of Pokemon. Because many Pokemon can have many moves. All right, great. Well, now that I've made this change here, I should also make a change to the serializer as well. So I'll come over to the serializer, not for the move, but rather I'll come over to the serializer for my Pokemon. Trying to keep this somewhat clean here. And in there, I'll go ahead and say that I want to, from the move app.serializers, import the move serializer. See, I have a hand up. Go ahead, Carlos.
Yeah, could you go back to the model? I think it was the Pokemon model where you were adding it.
Absolutely. Let me go ahead and do this portion here so I don't lose my train of thought.
Yep.
All right. And you're saying go back to models.
Yeah, so you're in the Pokemon class and you're doing the related name as Pokemon. If
Now,
I so
so the related
let's throw me up, yeah.
the related name isn't populating inside of Pokemon. Instead, the related name will populate inside of the move model. So here, by adding that related name, I am saying that there is a move, or excuse me, a Pokemon model that will be a list of objects.
Gotcha. Okay, I just had it flipped then. Thank you.
Of course. All right. Any other questions? All right. Fantastic. So now that I've made these changes, my serializer has been updated. I can actually have a many-to-many relationship. Let's go ahead and update all of our information here. So I'll say Python, manage PY, make migrations, because now there is a new migration to be created for the Pokemon model. And then I'll apply the migration. Great. So now the migration has been applied. I can have new Pokemon hold moves. Just gonna grab my very last Pokemon and bring in Blastoise. So let's say, I believe my last Pokemon is Blastoise. Let's see. Select all from, oh, this is the wrong database. All right. Select all from Pokemon app / Pokemon, limit 1, and then sending, of course. Can I have it descending? Cool. All right. So actually, our very last Pokemon is going to be Mewtwo. So let's bring that one in. I'll go ahead and say Mewtwo is equal to the Pokemon serializer. And I'm going to grab Pokemon.objects.last. And then from there, I'm just wanting to go ahead to add a couple of things here. First, I'm going to grab the Mewtwo itself. I'll go ahead and say Mewtwo.moves.add. I'll grab the move.objects.first.id. So that will add the ID. I'll then pass it into the serializer and print out the data. All right, so let's see this in action. First, I need to actually do my import statements here. So I'll come down below. and add it. Want to make sure that that stays on record. I don't want to lose it. Okay, so we go ahead and add it. We grab the information that we need. Here's my print statement now, where I have the ID of 6, the moves that have been added, which now has Psychic, the name of my Pokemon, and so on. So we just successfully applied a many-to-many relationship there. And now we have a Pokemon that can learn many moves. All right. Does anyone have any questions regarding how we applied a many-to-many relationship to our move application? Perfect. If there is nothing more to talk about there, let's go ahead and take a step back. All right, we just looked at our entire database process, and I think we did a drawing yesterday where we spoke about the monster of Django. We have been able to speak to our database so far. Our database is able to successfully return a response to my model, right? My model can talk to PsychoPG, PsychoPG can then talk to my database, and the interactions there have been working fantastic. Well, then I applied a model serializer, which has allowed me to grab data in JSON. But I still haven't gone into the portion of actually, hey, how do I program this URL to even route to the Pokemon model? Or how do URLs even work altogether? Well, before we can start talking about that, we need to talk about the Django server. So the very first question to ask is, what does Python manage py run server actually do? I'm going to go ahead and exit here. I'm actually going to run that command. So when you use the run server command, what happens is Django, again, the entry point is always going to be through manage py, and then it's going to move over to our settings. When it moves over to our settings, it's actually going to take a look at all of our variables that we have here. And it's going to create a dictionary of key value pairs, where the key would be debug, the key would be secret value, and so on. Installed apps would be a key, where the value would be the list of installed apps. It would program the middleware. And from there, we'll take a look at our WSGI application. We'll take into consideration everything that's falling here. And what it's going to do is it's going to build a small server utilizing Python. That server, although it is very good for development, cannot handle multi-proxy. It can't handle proxy passes. If we're receiving a ridiculous amount of requests that are maybe a millisecond apart or even coming in at the same time, the server wouldn't know how to handle that. So this is strictly just a development server, nothing else. Well, let's see what happens when I click on this. So this 127.0.0.1. Well, what that did is it ended up creating this worked, the install worked successfully. Congratulations. And it tells me, hey, you're now in Django. And it tells me you are seeing this page because debug equals true is in your settings file and you have no configured URLs. All right. So this already comes built into Django. If we go into inspecting this, we can take a look at kind of the console here, or excuse me, the source as to where everything is coming from. So we see there's an index HTML that's being loaded. If we take a look at the network tab and we send this application, so there's the SVG image that's coming in here. Let's see what else we can find. So here we can see from 127.0.0.1. Okay, it's not letting me find. I'll do this. All right. We can see that there was a request. That was a GET request. There was no origin crossing, which we'll learn about cross-origin resource later on. And here it tells me what it returned. It returned a content type of HTML, some cross-origin information, date. We can take a look at the request headers and everything that's coming back. But what's important to me is, hey, I received a index HTML file strictly from Django. How's that happening? Well, it says, hey, debug is equal to, because I didn't have any altered routes and debug was equal to true, that's why I'm getting that information. But where's this coming from? Well, everything starts at the project level. In the project level, we have this urls.py. And in urls.py, this is where we expect to define our paths. We've already seen the admin site and how it works. We saw that on the very first day that we worked with Django. And when you type in HTTP 120.0.1 and then 8000/admin, what it does is it actually sends you to the site URLs. But admin isn't some magical thing. If we take a look at admin, you'll see that there's actually quite a bit of administrative information and classes that have been displayed there to include different sites. Let's see, admin site. There you go. And here we can see that there's a lot of URL patterns that is being created kind of programmatically by figuring out what models we have inside of our register file. So this is where all the information is coming from there. But what if I want to build my own URL patterns? All right, so for example, let's start off with something simple. I just want to build URL patterns that will tell me if I'm looking at a square, a circle, or a triangle. Well, what is path? Let's take a look at path. So path is a pattern for a route pattern. Let's take a look at that route pattern. All right, so that route pattern is using some sort of regex location here. We can see that it expects a route that has been privatized, a name that is defaulted to none, so I don't actually have to give a name, and then an is endpoint being equal to false. Great. So this tells me that this route pattern just needs a route to actually exist. Great. I'm taking a look at some of the inner code. I somewhat understand what's going on here. Let me take a look at what happens when I look over path. So when I look over path, I'm getting, hey, if you want to create a new path, you need a route, a view, some quirks, and a name. So a route, and actually let's do this way. So we need a route, a view. We're not going to worry about quirks, and we need a name. All right, so a route is just a series of characters to identify a URL pattern, i.e. API/v1/square. Right, this should look familiar. This is almost how when we were working within React, we were utilizing path to specify the information. All right. Well, now in a view is a function that will return a response when the URL pattern receives a request. So to make this a little bit more functionality or a little bit relatable to what we've done in the past, in React, I had something that looked as such. where I had a path that held a URL pattern, such as, let's go with characters. From there, I had a element where an element, although we may call it a component that returned HTML, at its purest form, it was a function that returned HTML. All right, so that view is pretty much the similarity to element, where it's returning a function. And then finally, we have a name parameter. And the name parameter is to be able to do reverse calls or conduct reverse calls to URL patterns within the Django environment. All right. Well, let's take this into consideration then. When I created a view function, or excuse me, when I created a component in React and I was returning JSX, I had to explicitly return actual HTML or integrated JavaScript in HTML, as we know JSX. Well, in Django, what we are required to return is an HTTP response or a JSON response. So it returns JSON or HTTP. For today, we're going to focus on what an HTTP response might look like. Well, let's get to work then. We're going to go from Django, HTTP, and import an HTTP response. All right. Well, now I'm going to create my new path. In this path, I'm going to have an API. Actually, let's make it simple. Let's just say I want to see squares. Well, there's my URL pattern or the route that I want to be implemented. But now I know I need a view. Instead of creating a whole function, I'm just going to do a lambda function here, where for X, I will return an HTTP response holding an H1 element saying squares. I believe that's right. So let's go ahead and take a look here. We come over to our server. Now that I have some altered routes, you'll notice that if I refresh the page, it's actually going to give me, hey, these are the only two URL patterns that you have programmed. Now I want to go over to squares. Well, now I'm seeing squares populate. Well, how is this happening? Let's take a look at our drawing here. And you'll notice as this drawing continues, the Django server is just going to continuously get longer and longer, right? So a client sends a request. That is received at URL, or excuse me, at the project. So at the project level, URL patterns, where a path handles the request to match it to a view. And then finally, views receive the request and return a response. Right, so there's our monster. A request comes in. comes in through the server, goes to settings dot, or excuse me, to our project folder. It finds the URL patterns and it takes a look. It says, hey, there's no such thing as an empty string, so we're not going to be able to handle that. Well, if I come over here and I send an empty string, it doesn't know how to handle that. There's no response coming back from my server. It's just giving me an error page telling me, hey, these doesn't exist. These are the only two URL patterns that you have. And that even tells me inside of Pokedex project.urls, these are the only two URL patterns that you have currently configured. All right. If I go over to admin, well, that takes me to the admin site, which we know is registered, and it comes built in with Django. All right. And if we go to squares, now it matches the series of characters that we have here as a URL pattern, triggers the Lambda function, and executes that response of squares. Does anyone have any questions over how the Django server is actually receiving request and returning a response? All right, let's take this a step further now. Gonna take my squares. I'm gonna change it from squares to have triangles. Oh. Jesus. And let's have circles. Well, now all three of those URL patterns exist. If I come over and I take this off and I make it triangles, you'll see that triangle show up. If I come over and I go to circles, we'll see that circles shows up. All right, everything independent to their one function. Now, although this is a Lambda function, this is still a function. But we're passing in this X parameter. What could X possibly be whenever we're talking about a view? Can anybody take a guess?
The view component with the app.
The what component again?
I don't know, the app views component that's getting returned.
Got it. Yeah, so it would be the request itself that's coming in. Let's take a look at this view. I'm actually going to creating one. I'm going to create a function called squares. And this function is just simply going to return an HTTP response that matches the one down below. All right. Well, now I want to apply this function of squares. Rather than having it be triggered through a Lambda function, I want squares to be triggered inside of this path. I'm going to do so as such. All right, let's see what happens here. That worked great for circles. I'm going to try squares now. Well, here I'm getting an error. It's telling me squares takes 0 positional arguments, but 1 was given. That raises the question, what is that 1? In this case, we know that what we're receiving is the request. If I go and refresh my page now, it works perfectly fine. Well, what is request? Let's take a look. You can go ahead and just simply print request. Gonna actually do this number so that we can actually take a look here. So this logic isn't going to be executed unless I'm consistently refreshing the page, right? This view isn't being called unless the URL pattern is being called. So when I refresh it, we see, what are we seeing here? Here you go. We see a WSGI request, get, and it tells me the URL pattern that it was executed to. There's got to be more information in there. So I wonder what happens if I do request.headers. And I refresh my page. Well, when I send something like request.headers, I'm getting the content length, content type, the host that's trying to make this request, where it's coming from, cookies that may be coming from this browser. All of the information that we have seen in requests before is being included here. Well, I've worked with APIs before, and I know you guys are at this point interacted with plenty of APIs, where some of them might actually have an authentication key that is required to be included in the headers. This is where we would be grabbing that information from. We would check the headers and then do something like dot token or dot bearer, depending on what it is that your API had. I know there's authorization that also comes in, and you could send it, and that might even cause an issue in this case if there is no authorization header being handled. But that's where you would find it, is inside of the body of the request. The request is just simple information of who's actually sending the request and what might be sent within the request body. So in this case, let's go ahead and take a look at that. So request.body. Well, currently in request.body, we can see that it comes in as a binary string, and there's nothing in there. There's nothing that's being sent to this URL pattern inside of the body. Luckily, we've already seen a binary string before, so we know how to work with that if we need to. We do it by utilizing JSON.loads. But now I know where I can find the body of a request, so I can find some data if I need to. All right. I know how to build a view now. This is a function-based view that accepts a request and returns an HTTP or JSON response. Well, now let's start adding some logic inside of this view, because otherwise, what's the whole point? Right? I want to have this view just simply return what would be an area of a square. So let's go ahead and say area of square. And for now, let's just say that it's 2 times 2. Well, what we can do is turn this into an F string and turn this into area of square and just add our area of square there. Well, now when I send my request, I get area of square is 4. It's just simply accepting the logic and returning the HTTP response. All right, up to this point, does anyone have any questions? Perfect. If no one has any questions, then let's start talking about URL parameters. We've seen URL parameters being implemented before. For example, if I have something like, hey, I also want to see character details in my path, I would have done something along the lines of characters /ID/ to be able to return the ID in my use params hook. And then I would have something like an element of character details page. We know that React Router DOM was able to identify parameters in the URL pattern through the semicolon. Well, how would we be able to do that? Through Django. In Django, what we actually accept is going to be these arrow brackets. And in Django, we can actually specify what kind of type we're receiving. I can say, hey, I'm going to receive an integer and then the name of the variable to be interpreted as. Let's say base. And again, I'm going to receive an integer and the name I would like the variable to be interpreted as. All right. Let's see what happens now. Here's my URL pattern. I have squares. I know that I'm going to need height. Let's go ahead and pass in 1. I know that I'm going to need a base. And I mean, this one, we don't even need a base since it's a square. We could just take in the height. Leave it simple. When I'm getting another error here. It's telling me type error, add squares height /1. And it says the squares view got an unexpected keyword argument of height. All right. Well, I knew that I named it this way, where it's an integer of height. But what it's saying is my view squares is now receiving an argument, and it doesn't know what to do with it. The reasoning is because I haven't passed in height into the function. Now when I refresh it, it works perfectly fine. Let's go ahead and print height for now. Refresh the page, we can see height 1 being represented down there. And because of that, I can do something like height to the power of 2. All right, height square would return to me the area of a square. So this tells me that the area of a square is 1. If I do something like 3, I get 9. I do something like 5, I get back 25. Again, it follows the URL pattern, squares, height, slash, and it identifies this as an argument. And then slash. So as of now, there's 2 arguments that are being passed into squares. What are those 2 arguments?
Request and height.
Perfect. Height, or excuse me, request, which is automatically passed into every single view. And height, which is coming from the URL pattern itself. That is what I named it here. The text needs to match, otherwise it will throw an error. If I change this to say width, and I go to refresh my page, I'm going to get an error because I'm still trying to pass in height and it doesn't know how to handle that. So it needs to match the same thing that you have in your URL pattern. All right, any questions on how we pass parameters through a URL pattern inside of Django? If there aren't any questions, then let's go ahead and walk through the process of applying it to triangles. Or let's tackle down circles here. How do I figure out the area of a circle?
Pi r squared,
All right,
maybe.
let's go ahead and do an H1. Area of a circle is circle area. And let's do the whole H1 process there. Right, so circle area. So we're saying that to figure out the area of a circle, we would need math. So let's import math. And we said math.pi times whatever it is that we're being passed in, which is, in this case we'll be receiving the radius. So let's just say radius squared. All right. So somebody other than Nick, where would this radius be coming from?
You would have to
URL.
pass it in
I would have to pass it in from where?
the URL. You have to go down a path, add radius, / integer, or inside the, yeah, and then radius again, and then close it out.
All right. Awesome. Well, now it's inside of the URL pattern, and it looks like I'm trying to use it inside of the function, but the function doesn't know about its existence. What's missing?
After request, got to put a comma and pass in radius.
Nice. Let's see this in action now. So here we're going to go ahead and add circles, radius, and let's pass in 2. Oh, looks like we have a lambda function still being activated. So there's something else that I messed up. Can anybody tell me what's missing?
Yeah, get rid of the lambda function and instead call circles or whatever the name of the circle view is.
Perfect. And just to make sure everyone's tracking, we're not actually calling the function, right? We're just dictating, hey, this is the view that's going to be responding. But we're not going to call it within that path. There you go. We get area of a circle is 12.566. Great. Now the last portion, which is going to be our triangle. Well, I'm not going to complicate it by asking everybody to remember some sort of math. I'll go ahead and give us all the functionality here. So we're going to do triangle, which we know receives a request, and we know returns an HTTP response. All right. Now a triangle is just base times height divided by 2. So we know in this case, we will need base and height. So I'll say triangle area is equal to base times height. And we'll go divided by 2. All right. Awesome. So now the triangle view. How do I go ahead and start applying this, Aaron?
So in the path for triangles,
Mhm.
you'll after the slash do base and then another slash and then throw a integer for base and then slash for height as well. And then another slash integer height. And then a final slash. And then pass it in to the triangle function as well after request. We'll pass in base and height. And then take out that lambda function as well in the path. And set the view to triangle.
Nice. All right. Let's go ahead and see what this does. I'm going to come over, go to triangles. I'm going to say, hey, what I need first will be the base. In this case, the base, let's do 2. For the height, let's do 5. And see what that returns. Well, then it tells me the area of a triangle is 5, which is what we expected. All right. Does anyone have any questions over how we created these views to return HTTP responses and how we created those URL patterns? All right. If there are no questions, let's do a quick recap over everything we've done today. Starting off with associations, we covered off with models, starting with a one-to-one relationship and how that affects our serializers. We then moved into our many-to-one relationship, utilizing the foreign key field and how that affects our serializer with the emphasis of many equals true. We then move into our many-to-many serializer. And we also talked about the underground table that is managed through Django to make this connecting table between authors and books and how that affects our serializer as well. From there, we moved over to our Pokedex project where we created the where we created the Move app with an additional model, an additional serializer, and a validator as well. We grabbed that move to then create a relationship of many to many between Pokemon and moves. We altered the serializer for a Pokemon to be able to grab all of those moves as well. And then finally, we moved on into URL patterns. How do URL patterns work? They fall into the path function, which the path function requires a route, a view, and does not require, so I'll just go ahead and do this number to make sure that we understand that that is not a requirement, a name, to be able to make reverse calls to URL patterns within the Django environment. We'll be covering that here shortly once we start going into testing for the actual API views. We then talked about views, what they are. Well, views are functions that receive a request and return an HTTP response. That request falls into every single view, whether we utilize the request or not. It is still passed to every single view. These are function-based views. Moving forward, we will be utilizing class-based views. We'll see what that looks like in future lessons. We also covered how to pass in your URL parameters. We specified that they can be identified as either integer or string, that they are annotated through these arrow brackets, and that they are then passed to the dictated view. At this point, does anyone have any questions over any of the material that we covered today? Carlos, let's hear it.
So, and the parameters only, or the URL parameters, can they only be integers and strings? You can do Boolean and other stuff.
They can only be integers and string by default. You can do something. You could create your own URL register, which will be able to identify other parameters like true or false. But built in, only string and integer are coming out of the box.
Thank you.
Okay, perfect. All right, Daniel?
So I'm assuming in the future, we're going to be using React to basically be passing in the URL parameters that we're going to be adjusting with this.
Yes, so not React itself, but whatever front-end framework. I want to say that it's JavaScript. I don't want to put it just to React. Any front-end framework that can make a request, or even a back-end framework that can make a request to your server, that's what we'll actually be utilizing this URL pattern to receive a response.
Can we still maintain the functionality of not refreshing the page though, with passing in these parameters?
Oh, I see what you're referencing. So yes, the way that's handled, oh man, I don't want to get too far into systems design. Let me see what I can do here. All right. So the way that's handled is we're going to have a parent server that will be called Nginx. This is going to be a proxy pass server, and it's going to have all of our static files working independently from our backend server in GUnit. And to answer your question, well, inside of our static files, this is where our React application would live. And inside of our backend server, this is where where Django, oh man, I cannot spell, would live. Well, now how does that handle URL patterns? Because as of now, we have a static site, right, where everything is inside of without refreshing the page. How do I do that? Right? Because as of now, if the moment that I put it inside of a server, technically it's going to need some sort of refreshing of the state. Well, what we do is we have an if statement that works here, where if any URL pattern starts with API slash all the URL patterns that go to API slash something will be automatically directed to the backend server. And anything else will be handled by Nginx static files. So this way, if I'm refreshing my server, or if I'm clicking refresh on the static page itself, it's not actually refreshing anything. It's keeping it all within the React application, because Nginx is just serving the React application over and over again, regardless of how many times I refresh, right? Where when I'm sending something through the API, that's actually sending a request over to the backend server. Does that answer your question, Dan?
It does. So basically, this allows us to make API calls, and then once we have the API call and all the information we want, we can mess with it in React and not sit there and make a million API calls while messing and stuff with React.
Right. So you could also have like a use effect. Oh, if you're talking about how to handle it within React, we're going to be covering that here shortly once we go into the full stack process. But everything's still going to remain stateless.
Thank you.
Of course. Any other questions? Perfect. If there aren't any other questions, I'm going to go ahead and stop our recording here.